USS Gerald R. Ford cost $13 billion to build, 12 years of construction, thousands of workers, cutting-edge technology that doesn't exist anywhere else on Earth. But here's what nobody tells you. Getting planes off that deck is harder than building the entire ship. Right now, America's newest supercarrier can go days without launching a single aircraft. Not because of enemy action, not because of weather, because the systems designed to launch planes keep failing. The Navy spent billions perfecting launch technology, yet pilots still can't rely on it. Building the carrier was the easy part. Making it actually work? That's where the real battle begins. Think about that for a second. You can construct a floating city that weighs 100,000 tons, pack it with nuclear reactors, house 6,000 sailors, and sail it across oceans. But putting a fighter jet in the air from that deck? That's the challenge that keeps admirals up at night. And the reasons why will shock you. Introduction. The Ford-class carriers represent the peak of American naval power. These vessels carry more firepower than most countries possess in their entire military. They project American strength to every corner of the globe. But there's a dirty secret the Navy doesn't advertise. Launch operations are so complex that even our most advanced carrier struggles to maintain them. We're talking about systems that fail every 181 launches when they should last for over 4,000. We're talking about landing gear that breaks down after just 48 aircraft recoveries instead of the promised 16,000. The construction phase? That's engineering. Flight operations? That's controlled chaos where one mistake costs lives. What's your take on modern carrier operations? Drop your thoughts in the comments below. The construction reality. Let's start with what it takes to build one of these monsters. The Ford took 12 years from first steel cut to commissioning. 12 years. That's longer than it took to fight World War II. Northrop Grumman had to organize thousands of individual parts. Pipes, cables, shafts, rudders, electrical systems, weapons elevators, radar arrays. Every single piece had to fit perfectly into a design so complex that they used digital models just to make sure components wouldn't clash during installation. The shipyard employed a technique called modular construction. They built massive sections on land, welded them together, then lifted these superlifts into the dry dock. Each section weighed hundreds of tons. The precision required was insane. We're talking about tolerances measured in fractions of an inch on a ship that's nearly 4 football fields long. But here's the thing. Construction follows a plan. Engineers design systems, workers install them, inspectors verify everything meets specifications. It's methodical. Predictable. Sure, problems arise. The Ford faced delays with its electromagnetic catapults and advanced arresting gear. Costs overran by 22%. New technology always brings headaches. But ultimately, you're building according to blueprints. You control the environment. You set the timeline. Compare that to flight operations. You're dealing with variables that change by the second. Wind speed, sea state, aircraft weight, fuel loads, pilot experience, equipment wear, weather conditions. And you're doing all of this on a deck that's pitching and rolling in the ocean while managing 70 aircraft that cost more than $100 million each. The Navy had to invent entirely new systems for the Ford. The electromagnetic aircraft launch system replaced traditional steam catapults. Sounds great on paper. Uses magnets instead of steam pressure to fling aircraft down the deck. More efficient. More versatile. Can launch everything from heavy fighter jets to lightweight drones. Except there's one problem. It keeps breaking. Where technology meets reality. The EMALS system was designed to go 166 launches between major failures. That's the specification. That's what the manufacturer promised. That's what the Navy paid for. Reality? 181 launches. Not even 5% of the promised reliability. In 2020, the system went down twice. Each time it stayed broken for 3 solid days. That's 3 days where the most advanced aircraft carrier on the planet couldn't launch planes. Think about what that means in combat. Your carrier battle group is supposed to provide air superiority, supposed to strike enemy targets, supposed to defend the fleet, but your catapults are broken. Your multi-billion-dollar warship becomes a very expensive, very vulnerable target, floating in hostile waters. Quick question. Have you ever been on a naval vessel? Let us know in the comments. The advanced arresting gear tells the same story. When a fighter jet lands on a carrier, it's screaming in at 130 knots. The deck is moving. The ship is rolling. The pilot has seconds to catch one of 4 arresting wires stretched across the deck. Miss those wires and you either slam into the barrier or go off the front of the ship into the ocean. Neither option ends well. The AAG uses a water turbine system to stop these aircraft. It's supposed to be gentler on the airframes than the old hydraulic systems. Supposed to last for 16,500 recoveries between failures. Again, that's the specification. The reality? 48 recoveries. 48. That's not even 1% of promised performance. Pentagon testing director Robert Baylor put it bluntly in his report. The Ford can launch aircraft, and it can fix technical problems, but it cannot do both simultaneously. That's not a ringing endorsement for a ship that cost $13 billion. But mechanical systems are only part of the puzzle. The real complexity comes from the human element. The human machine. Before we go further, please hit that like button and subscribe to the channel. Over 98% of viewers watch without subscribing. It costs you nothing but helps us tremendously. We appreciate your support. Building a carrier requires skilled workers, sure. Welders, electricians, engineers, shipfitters. But they work in controlled conditions. Climate-controlled facilities. Safety protocols. Lunch breaks. 8-hour shifts. Weekends off. Nobody's shooting at them. Flight deck operations? That's a different universe. The deck crew works in one of the most dangerous environments humans have ever created. Jet engines that can suck a person in and spit them out as mist. Propellers spinning fast enough to decapitate someone who takes one wrong step. $100 million aircraft taxiing within inches of each other on a surface that's constantly moving. Do all of this in a noise environment so loud you can't hear yourself scream. Oh, and the temperature from jet exhaust can melt your skin. The Navy uses a color-coded system for deck crews. Yellow shirts are aircraft directors. They guide planes around the deck using hand signals. Purple shirts handle fuel. Red shirts deal with ordnance and crash rescue. Green shirts operate catapults and arresting gear. Brown shirts are plane captains. Blue shirts are aircraft handlers and tractor drivers. White shirts are safety observers and quality control. Each color represents a specialized job that requires months of training. And here's the kicker. The average carrier sees 200 new sailors arrive every single month. Constant turnover means constant training. You're always breaking in new people while maintaining peak operational tempo. Shore-based training can only teach so much. The real learning happens on deck. Studies show it takes many weeks just to qualify a deck for handling individual aircraft. Then many more weeks at increasing intensity to perfect the coordination needed for rapid launch and recovery cycles. If that training gets cut short by even 2 weeks, the entire crew feels the strain. One carrier that had its workup period shortened by just 14 days had to complete training during a major exercise. The referees had to adjust their evaluation standards because the crew was so overwhelmed. That's how critical preparation time is. And we haven't even talked about the pilots yet. The pilot's nightmare. Carrier landings are universally recognized as the hardest thing a pilot can do. Test pilots and Navy aviators all say the same thing: it's dangerous. Approaching a carrier deck, you're flying at 130 knots. The ship is steaming forward at 20 knots. So relative to the water, you're closing at 150 knots. The deck is moving side to side. It's pitching up and down in the swells. Your target is a small section of angled deck that's maybe 300 feet long. You have to maintain the perfect glide slope. Too high and you miss the wires. Too low and you slam into the back of the ship. Pilots make between 200 and 300 small corrections during the final 18 seconds of approach. 18 seconds. That's all you get to nail a landing that, if you screw it up, either kills you or humiliates you in the debrief later. The plane hits the deck at 800 feet per minute. That's not a landing. That's a controlled crash. The arresting wire has to catch your tailhook and stop a 30-ton aircraft traveling at landing speed in just 320 feet. The deceleration forces are brutal, but it works, usually, except when the advanced arresting gear fails, which, as we discussed, happens way more often than it should. When the AAG goes down, flight operations stop. Planes in the air have to divert to land bases if they're in range. If not, they have to hope another carrier is nearby. If not that, they ditch in the ocean and hope the rescue helicopters get there fast. Launch operations are only slightly less terrifying. The Catapult has to accelerate an aircraft from 0 to 160 5 miles per hour in less than 300 feet. The forces involved are incredible. The shuttle that connects to the aircraft's nose gear is powered by either steam or electromagnets, depending on the carrier class. When it fires, you go from standing still to flying speed in about 2 seconds. Quick one for you. Would you trust your life to a Catapult launch? Comment below. If the Catapult fails mid-stroke, the aircraft doesn't have enough speed to fly. It rolls off the front of the deck into the ocean. Pilots have ejection seats for exactly this reason. But ejecting near a carrier is insanely dangerous. You've got a ship moving at 20 knots that weighs 100,000 tons. If you eject wrong, the ship runs you over. The Navy practices these procedures constantly because the margin for error is non-existent. Compare this to construction. When you're building the ship, you can stop work if conditions aren't perfect. Weather's bad? Delay the lift. Equipment's malfunctioning? Shut down until it's fixed. You control the schedule. You control the environment. Flight operations don't have that luxury. The mission dictates the tempo. If you're providing air support for ground troops, those troops need strikes when they need them, not when your Catapult decides to work. If you're conducting combat air patrol, you need planes in the air 24/7, regardless of sea state or equipment condition. The operational tempo grind. Let's talk about what sustained operations actually look like. The Ford's first major deployment ran from May 2023 to January 2024, 239 days away from home port. The ship logged over 10,000 sorties. That's 10,000 individual aircraft launches and recoveries. They conducted 43 underway replenishments, which means other ships pulled alongside to transfer fuel, food, ammunition, and supplies while both vessels are moving. The carrier sailed more than 83,000 nautical miles. That's almost 4 times around the Earth. And this was during a deployment that got extended multiple times because of the Israel-Hamas war and regional instability in the eastern Mediterranean. Current operations are even more intense. The Ford left Norfolk in June 2025 for what was supposed to be a routine European deployment. Then in October, the Pentagon pulled the carrier from the Mediterranean and sent it to the Caribbean. As of right now, the Ford has been at sea for over 200 days. The crew is exhausted. Equipment is wearing faster than planned maintenance cycles can handle. The Navy's Chief of Naval Operations is pushing back hard against any further deployment extensions. Why? Because long deployments destroy readiness. Machinery breaks down faster when it's running constantly. Maintenance backlogs pile up. Costs skyrocket because you're doing emergency repairs instead of planned maintenance. And the crew burns out. You can't replace an entire carrier crew in the middle of deployment. You can rotate some personnel, but the core team has to stay. That means sailors spending 7, 8, 9 months straight at sea, away from families, working 12 to 16-hour days, living in cramped berthing spaces, eating the same food, breathing recycled air, dealing with constant stress. During construction, workers go home at night. They see their families. They sleep in their own beds. They get weekends and holidays off. The psychological toll is completely different. And here's something most people don't realize. Carriers need extensive maintenance between deployments. A typical cycle used to be 32 months from the end of one maintenance period to the end of the next. That includes deployment time, training time, and maintenance time. The Navy has to balance three competing goals: deploying carriers to where they're needed, giving crews enough time home to maintain quality of life, and conducting thorough maintenance to keep the ships operational. Stretch deployments too long and the whole cycle breaks. Ships come back needing more maintenance than planned. That pushes back the next deployment, which means another carrier has to fill the gap, which extends that carrier's deployment. The Navy only has 11 carriers total. When one is in extended maintenance, one is deployed, and one is working up for deployment, you've only got 8 carriers to cover the entire world. It's a juggling act that never stops. The ultimate complexity. So why is launching a carrier more complex than building one? Because building is engineering. Launching is art, science, and survival all mixed together under impossible pressure. When you build a carrier, you're working toward a defined endpoint. The ship either meets specifications or it doesn't. You can take your time. You can fix problems. You can test and retest until everything works. The environment is controlled. The variables are limited. You're dealing with physics and materials science, which are predictable. Last question. Which branch of the military do you respect most? Share in the comments. Flight operations throw all that certainty out the window. You're coordinating hundreds of people making split-second decisions. You're managing equipment that's being pushed to its absolute limits. You're dealing with weather you can't control, sea states you can't predict, and combat situations that change by the minute. One mistake and people die. One equipment failure and a $100 million aircraft goes into the ocean. One miscommunication and you have a deck fire or a collision. The Ford struggles with EMALS and AAG prove the point perfectly. Engineers designed incredible systems on paper. They tested them extensively. They spent billions developing the technology. And yet, when those systems face real-world operational stress, they fail at rates nobody predicted. Building them was hard. Making them work under combat conditions? That's exponentially harder. Our sailors and naval aviators deal with this complexity every single day. They train relentlessly. They maintain standards that most people can't even imagine. They put their lives on the line operating some of the most dangerous machinery ever created. And they do it to project American power and protect American interests around the world. That's why flight operations will always be more complex than construction. You can build the perfect ship, but if you can't launch aircraft reliably, that ship is just an expensive floating hotel. The real measure of a carrier's capability isn't how much it costs or how advanced its technology is. It's whether those catapults fire when the pilot needs them, whether those arresting wires catch when the jet comes screaming in, whether the crew can maintain operational tempo day after day, month after month, under conditions that would break most organizations. Conclusion. The USS Gerald R. Ford represents the absolute peak of what American shipbuilding can achieve. But the men and women who operate her? They represent something even more impressive. The ability to take that incredibly complex machine and turn it into a weapon of war that actually works. If you found this valuable, hit that like button and subscribe. We'll see you next time.